Employees from the Los Angeles Department of Water and Power, CH2M Hill, the Design-Build Partnership of Bernard Construction Company Incorporated, and Boyle Engineering are hard at work on the Owens Dry Lake. Armed with world-class science, engineering, and 22nd century technology, they are improving the quality of life in the Owens Valley by ending the dust problem from the Owens Lake playa. Owens Lake is the remnants of a large prehistoric body of water 60 miles long and over 300 feet deep. It is also the greatest environmental challenge faced by the city of Los Angeles. Thousands of years ago, a climate change reduced the Owens River. By the time European settlers entered the Owens Valley, the lake, with no outlet, had become extremely salty. Farming and ranching further reduced the river, and in 1913, the Owens River was diverted into the Los Angeles Aqueduct. By 1929, the lake had all but dried up and became a major source of dust. For 50 years, millions of tons of dust blew in the surrounding towns and environment, reducing the quality of life for people and animals. In 1979, concerned parties formed the Owens Dry Lake Task Force to investigate the dust problem. It took 20 years of intensive research for scientists to determine the best methods for dust control. Many solutions were discussed and discarded. The quality of life and the health of the environment of the Owens Valley were at stake. The final solutions were created with sound and valid world-class science and engineering. On July 27, 1999, the city of Los Angeles signed the Memorandum of Agreement committing to at least 13.5 square miles of dust controls to be working by the end of 2001. The state implementation plan divided the lake bed into 4 zones. The Department of Water and Power decided zones 1 and 2 in the north were to be treated first. Shallow flooding was the selected dust control method, since it was the quickest way to solve the problem in this area. On September 11, 2000, Los Angeles Department of Water and Power employees began construction on the Lubkin Creek spill gate. This gate will supply water to the shallow flood dust control system on the Owens Lake North Sand Sheet. Up to approximately 77,500,000 gallons of water per day can be released out the spill gate onto Owens Lake. In order to construct the 645-ton structure, department construction crews carved out a 100-foot wide sidewall section of the Los Angeles Aqueduct. 4 12-foot diameter, 38-foot long, 5/8-inch thick steel pipe sections, weighing 31.5 tons each, were placed in the dry bottom of the aqueduct. Welded together, they spanned 150 feet to bypass the breach and continue to flow 350 cubic feet per second of water. Department employees were then able to build forms and pour concrete to create a structure 20 feet high, 30 feet deep, and 50 feet wide. Bernard Construction Corporation Incorporated took over the installation of this 60-inch steel pipe from this point to the dry lake bed. 500 yards from the spill gate, the 60-inch line passed under State Highway 395. Care was taken to disturb as little of the roadbed as possible. A steel box was used to prevent collapse of the trench during the highway crossing. To prevent inconvenience to travelers, the work was completed during the midweek as quickly as possible. From the highway, the main line stretched 3 miles to the Owens River. At all times during the excavation, an archaeologist and a Native American representative surveyed for signs of ancient humans. A large power shovel scooped 2 tons of dirt from the trench at a time. A 7-story crane lowered the pipe into place, and it was welded inside and out. A protective and anchoring slurry of concrete was poured onto the pipe with a machine called a Henry's. Sandy soil from the trench was loaded into a hopper mixed with water and cement and poured over the 60-inch line. The anchored pipe was reburied and the soil compacted. The saved topsoil and native vegetation seed were used to rehabilitate the site. The Owens River had to be protected from the disturbed earth and water produced by the excavation. An environmental engineer from Bernard Construction Company and field biologists from the Department of Water and Power began to take water quality measurements before the area was disturbed to establish a baseline standard to compare during construction in this sensitive area. A barrier of steel plating kept mud and water contained within the construction zone. The Owens River itself was piped across the site to avoid contamination. Pumps were used to lower the groundwater table, allowing for easier excavation. A steel excavation box prevented the slumping of mud back into the trench and provided a form for the steel-reinforced concrete protective encasement. Daily water quality testing continued during construction and for a period of time afterwards. 4 miles from the spill gate, the steel pipe connects to a manifold that divides the water flow into two 48-inch fiberglass reinforced pipes. 15 miles of these pipes carried the water out onto the north sand sheet. To avoid corrosion by the salty soil and recycled salt water, fiberglass and plastic pipe are used to distribute water on the playa. 13 miles of 24 to 12-inch submains distribute water out to the lateral fields. 90 miles of 12 to 6-inch PVC laterals supply water to 5,300 adjustable alfalfa valves that release water onto the surface. Once the water is released, it flows towards the center of the lake. Excess flow is stopped by levees and captured in 39 miles of surface and subsurface drains. Perforated 16 to 8-inch flexible pipe wrapped in an envelope of sand and permeable geofabric sleeves collect and return the water to a series of chambers. From here, the salt water is recycled to the distribution network, where it mixes with fresh water for application back onto the playa. Construction on the playa required special equipment. Only low-ground pressure vehicles with wide tracks or balloon tires were able to operate in the wet areas. Standard tracks and tires sank and became hopelessly mired. The closer you got to the low points on the playa, the worse it became. Rubber mats and huge wooden beams were used to give sure footing for the tracked shovels digging in these areas. Every time a piece of heavy equipment moved, its footing had to be relocated. As work continued, so did the protection of the environment. The snowy plover is a shore bird that builds nests on the Owens Lake playa. The billions of brine flies that hatch in the warm, shallow brine pools and wet areas are food for its young. Construction traffic had to cross nesting areas. Ironically, the 39 miles of elevated roadways provide a windbreak that the birds like to use to build their nests in. To help protect the plover, every program employee was educated about the bird and its habits. Biologists from the Point Reyes Bird Observatory marked every nest with a survey marker and streamers. Lower speed limits were posted, and entry into some areas was restricted. On September 18, 2001, Los Angeles Department of Water and Power construction crews started work on the Cartago Spillgate, built to supply fresh water to the southeastern portion of the lakebed in zones 3 and 4 in the south. In Phase 2 of a multi-year program, 4.5 square miles of managed vegetation and seasonally flooded areas will be created. Owens Lake saltgrass seed harvested both from natural pastures and wetlands on the playa edges, and a local farming project will be used to initially anchor the playa surface. The department, Great Basin Unified Air Pollution Control District, and CH2M Hill have collaborated in research on planting, irrigation, and drainage techniques. The results have shown that drip irrigation works very well for growing saltgrass on the playa when good drainage lowers the naturally high level of salty groundwater. The nerve center of the entire dust control system is at Keeler. Computer programs will use water flow rates, solar radiation, weather data, and other parameters to predict evaporation and control the flow of salt and fresh water needed for plant growth and to flush out excess salt. The dust control system will continue to be expanded and redefined into the immediate future. By signing the Memorandum of Agreement and complying with the State Implementation Plan, the City of Los Angeles has committed its resources to improving the quality of life and the environment in the Owens Valley.